Hello, welcome for today's video. My name is Kian Andy Delgado. I'll be talking about the rule of differentiation, mainly the product and quotient rules. But before we start, let's take a look again of the first 5 basic rules of solving derivatives. Those rules will still be used for today's topic. So, let's get started with the product rule. This can be used in a composite function, which means a product of two functions. In this rule, we cannot assume that the derivative of a product is a product of derivatives, unlike the sum and difference rule. For example, p of x equals x squared plus 2 times 3x cubed minus 5x. By using the pattern used in sum and difference rule, a different answer will be derived, which is a wrong answer. So, to correctly get the derivative of a product, you have to get the derivative of the first function times the second function plus the derivative of the second function times the first function. Using the example above, p of x equals x squared plus 2 times 3x cubed minus 5x. The first function, f of x, is x squared plus 2 and the second function, g of x, is 3x cubed minus 5x. To get derivative is the derivative of f of x times g of x plus the derivative of g of x times f of x. So we have 2 times 3x cubed minus 5x plus 9x squared minus 5 times x squared plus 2. Multiply each term. 2x times 3x cubed minus 5x is equal to 6x raised to the power of 4 minus 10x squared plus 9x squared minus 5 times x squared plus 2 is equal to 9x is raised to the power of 4 plus 13x squared minus 10. Combine similar term. Therefore, the derivative of p of x or f of x times g of x is 15x raised to the power of 4 plus 3x squared minus 10. As you can notice, this answer is different from the answer we get previously. Let's go to the quotient rule. Product rule and quotient rule are not the same with the sum and difference rule. The derivative of the quotient is not the quotient of the derivatives. Rather, it is the derivative of the function in the numerator times the function in the denominator minus the derivative of the function in the denominator times the function in the numerator, all divided by the square of the function in the denominator. For example, use the quotient rule to find the derivative of q of x equals 5x squared over 4x plus 3. The numerator is 5x squared and the denominator is 4x plus 3. Using the rule, the derivative of q of x is equal to the derivative of numerator, which is 10x times the denominator 4x plus 3 minus the derivative of denominator, which is 4 times the numerator 5x squared over the square of denominator 4x plus 3. Multiply those needed to be multiplied. So we have 40x squared plus 30x minus 20x squared all over the square of 4x plus 3. Then combine like terms. Therefore, the derivative of the function q of x is 20x squared plus 30x over the square of 40x plus 3. Now let's do it.
the way like sum and difference rule. Let's get the derivative of the numerator, which 10x, and the derivative of the denominator, which is 4. So, get 10x over 4, which different and wrong compared to our first answer.
And that's it. I hope you understand the concept of the product and quotient rule. Just remember this rule or formula below. So as a practice, let's try to solve the derivative of more functions.